So factoring, what does it mean? Factor means to rewrite an algebraic expression as an equivalent product. This times this times this. What we are going to need to do is undistribute the algebraic expression. So just like for the do now, we distributed, now we're just going to be working backwards, right? There is a whole process to doing factoring. Whenever you are asked to factor, we always look for a GCF first. No matter what, I determine, is there a GCF within all these terms? If there is, I start with that. If there isn't, then I start moving on to the next type. We have a difference of two perfect squares. So that's one of my favorites. I like seeing the difference of perfect squares. Normally, we would be given a squared minus b squared, right? Again, a and b being some sort of numbers that are perfect squares, such as 1, 4, 16, 64, 81, 144. And we undo this by doing a plus b, a minus b, right? That's one of my favorites because it's usually the easiest, but I do also need to know my perfect squares. Then we have trinomial factoring, in which we have two types of cases. Trinomial factoring when a is equal to 1 and when a is not equal to 1, meaning the leading coefficient. When your leading coefficient is equal to 1 and or not equal to 1. If you are dealing with a equal to 1, that's the basic AM method, right? What two numbers multiply to the last term and add up to the middle? A not equal to 1 is going to be our AC method. So a whole process to doing those. Whenever we have one variable, not just stick to quadratic, whenever we have one variable, we like to write it in standard form. We start off with standard form. That way we know what type of trinomial we are dealing with. Standard form being we're starting with the highest exponent and decreasing as we move to the right. So whenever I see one variable in my factoring process by natural, I just write it in standard form. All right, so let's do it. Starting off simple, working our way to more advanced looking problems. So for number 1, we have been given the algebraic expression 2x squared plus 4. First things first, I have it in standard form. Awesome. Next thing is, can I divide 2x squared and positive 4 by a common factor? Of course we can. We could divide 2 by 2 and 4 by 2. I'm taking out that 2. That's my GCF, right? And I am left with x squared plus 2. So I undistribute it. For number 2, I start off, is it in standard form? It is. And I start doing, what can I, if anything, divide 6x squared and 10x by? Well, we can divide both of these by 2 and also x. So we're taking out a GCF of 2x. We're left with 3x minus 5, right? Whenever we're doing GCF factoring, you're dividing each term by that. If you're good at this process, you don't need to show that division piece. If you find yourself having difficulty seeing why you're getting to a certain destination, then show it. The next one, I like to write it in standard form first. So I'm going to start with that. We got 15x to the 5th, 18x to the 2nd, right? It's not in standard form. Getting into the habit, it's one variable. We're going to write it in standard form, and then we're going to start this process. I can take out a common factor of 3 from the 15 and the 18, and an x squared from those x's. So I take out that 3x squared. I end up with 5x to the 3rd power, right? Again, laws of exponents, plus 6. X's cancel out there. GCF factoring, GCF always comes in front. Now, when you have multiple variables, such as 4, 5, and 6, when you have multiple variables, we're not going to rearrange anything. We leave it exactly as is, just because I'm not really sure what way they want me to do it. And sometimes by me rearranging it, I end up having to rearrange again. So I don't do it. I just start with the GCF factoring process. I can divide both these terms by 2, both these terms by x, and both these terms by y. And don't forget what a term means. A term is separated by pluses or minuses in some sort of algebraic expression. So we take out that GCF of 2xy, divide the first term by that, we end up with 1x plus, divide second term by that GCF, we have a 2. Y's and x's get canceled out. That's it. All right, number 2, again, number 5, same thing. I don't rearrange when I have multiple variables. I just leave it as is, and I just start doing GCF. In this case, we can get rid of 7 or divide each term by 7. X, y squared. X, y squared. I take out that GCF. Has to be in front, don't forget about it. I end up with 2x minus 3y. And last one, I do not rearrange anything that has multiple variables. I just go ahead and start doing my GCF factoring. So here I can divide 12 and 15 by 3. I can divide both of these terms by x squared, both of these terms by y, but not z, because that second term doesn't have a z. So my GCF is a 3x squared y to the first power times 12 divided 3, 4. The x squares cancel out. Y's, we're left with y to the second power. Again, here, if you want to write it in there, you're subtracting those exponents. And the first term contains a z. Plus, we got 15 divided 3, 5. X squares cancel out. Y's cancel out. So that's all we have. So whenever you have multiple variables, do not rearrange anything. Leave it as that. When you have only one variable, normally we will rearrange it.